For this, what we're going to be doing now is taking functions that we know, looking at things we want to do to them, and then write the new function that results as that particular transformation. First thing on my list is vertical compression by a factor of 2/7. Remember, vertical is what you see is what you get, and it's outside the initial function. So my transformed function, we'll call it g of x. I'm going to be taking that x squared. I'm going to write it like that to represent that I might be doing some more later to it. What you see is what you get, so 2/7 on the outside. Now that applies to both stretching and compressing. Generally speaking, fractions are compressions. Whole numbers larger than 1 are going to be some kind of a stretch. Now it also says I'm going to be reflecting it over the x-axis. So that means I'm taking my values and I'm going to flip them down. So if my original parabola was here, I want to flip it to be down there. So that means, since it's a vertical change, it happens outside, and therefore I tack on a negative to represent that change. If it had been reflected over the y-axis, or a horizontal reflection, it would be inside the parentheses. Vertical, it's outside. So my final answer, can I condense it all down? G of x is equal to a negative 2/7 x squared. And that would be the transformed version of my original f of x. All right, our next example has us taking f of x is equal to 10 to the x, horizontally stretching the entire thing by a factor of 2. Now, horizontal is inside the factor, vertical is outside of it, and since we're inside, we always do the opposite of what we would expect. So, my g of x function, if it was vertically stretching, it'd be outside. Since it's horizontally stretching, it's inside. Except, it's the opposite of what I would expect. So my answer, g of x is equal to 10 to the 1/2 x. I'm taking the half, and I'm doing the reciprocal of it. Another way I might write that a little more neatly, g of x is equal to 10 to the 1/2 x. There we go, a little easier to read. And again, that's that 2/1 flipped, because it's part of the horizontal, or the opposite of how it's written. And that's all I need to do to achieve this. I'm taking that x, and then making the necessary modifications. This example has us taking f of x is equal to the square root of x, and reflecting it over y, horizontally compressing it by 2/3, translating the whole thing down 1 unit. So, let's start with this reflection over the y-axis. Now, the y-axis is our vertical one, which means we're going to be flipping it around horizontally. So if this function goes like this, then flipping it is going to send us doing that. That's a horizontal change, so it has to happen inside the radical. So for my g of x, square root of, I'm going to give myself a little more room, negative x. So that negative is what's going to create that reflection over the axis. Horizontally compress the entire thing by a factor of 2/3. Well, again, we're talking about horizontal, so it's left, right, it has to be inside the function, and it's the opposite of what I would expect. So this is not just a negative x here. This is a negative 3/2 x. Lastly, it says to translate down 1 unit. Well, that's a vertical change, so I'm going to be doing that outside of my original function, so -1. And it's exactly what I would expect because it's a vertical change. So, f of x equaling the square root of x becomes g of x, which is the square root of negative 2/3 x minus 1 to affect all these changes. And remember, that's that reciprocal, since it's on that inside. So that's there, and that negative is my reflection. Everything is shown inside my transformed function. All right, let's take a moment and tie all these rules together on one last general statement. For example, say I have f of x equals x squared. And I'm using x squared as a kind of a default function in order to show all of these various relationships. Positive and negative. This right here will tell me whether or not I'm reflected, since it's outside, if it's a vertical reflection. So this will talk about any reflections over the x-axis, or a vertical reflection. If it's positive, then there is no reflection. If it's negative, then I have. Again, it's an outside the function, so this A will tell us if there's a compression or a stretch. Specifically, some kind of vertical one. Inside the parentheses, whether or not I add a positive or a negative, that will show me if I have a reflection over the y-axis. So if I want to reflect something over y, I include that there. That would create that horizontal. B, that's going to tell me if there is a horizontal stretch or compression. So if it's inside the parentheses, it causes that horizontal change. Positive, negative C is going to translate me left, right. It's inside the parentheses, so it's a horizontal change. So horizontal translation. Am I going to the right or to the left? The sign will tell me. So positive means I've gone to the left. Negative means I go to the right. And finally, D. And this will tell me about a vertical translation. And again, positive is up, negative is down. So really, I can have all these different things happen to my given function, and it's all a matter of knowing where to put that effect into my new equation. More or less, you need to know all 1, 2, 3, 4, 5, 6 of these rules. Once you've got them, though, should be a piece of cake.